A contemporary alternative to end-to-end flow control is node-by-node flow control based on virtual circuits. The idea emerged because the TCP/IP networks are based on end-to-end flow control, with IP being the connectionless service. On the contrary, for ATM networks and other virtual circuit-based networks, the underlying network layer protocol establishes a connection, and all the user traffic belonging to the same flow follows the same virtual circuit. Since all the flow is based on the same virtual circuit, it is easier to do something within the network to combat congestion, and that is the principal idea of node-by-node virtual circuit-based window management. First, we shall understand what are the limitations of end-to-end flow control that node-by-node flow control aims to resolve, and then we look at its implementation. Again, the reference is Gallagher and Bertsikis. An inherent problem with the end-to-end flow control is that it tends to be unfair to short flows compared to the long flows. What do we mean by long flows? Long flows, also termed as long sessions, are the ones which traverse over long hops, and because of such long hops, the round trip time is large, so the window is kept large to achieve better utilization, whereas shorter sessions have smaller window sizes. Imagine that an intermediate device receives flows both long and short. So since long sessions have more number of packets, so these are entertained with more priority because the default working of an intermediate device queuing and scheduling is first come, first serve. So more the number of packets for long session, more would be the likelihood for it to be served. The solution that is proposed is virtual circuit windowing. Virtual circuit windowing attempts to solve the problems faced by end-to-end flow control. Here, the design is such that a separate window is established for every virtual circuit for every intermediate pair of devices along the virtual circuit. The principal idea in node-by-node virtual circuit windowing is that the receiver avoids a situation where its own memory falls short to the incoming packets so that it does not have to drop the packets. So what it does is it generates acknowledgements, also called as permits, at a controlled rate. Since the receiver would be sending back the acknowledgement or the permit to the penultimate hop, or in other words, an intermediate device before it, so it will affect it in direct way, and it will affect the node behind the penultimate node in an indirect way, and so forth. This is termed as back pressure effect. For example, let's look at the scenario given in here. Given an origin and a destination, with each intermediate device with its own memory, if congestion builds up on the link shown to you here, the window which is just previous to this congested link would advertise lesser number of permits to its previous predecessor or the upstream node, which in turn would notify its predecessor, such that this notification travels back in a single hop manner right up to the sender, and the sender throttles the window and reduces the transmission. What we observe from here is that if we have a window size W and the number of nodes along the virtual circuit, we can establish a relationship between the number of segments that could be sent in a single window and the intermediate devices. We could afford a larger window if the intermediate devices are many, and vice versa. A typical value for this 4 or 5 hop network is 4 or 5 segment sized window. If we use this node by node virtual circuit based windowing in conjunction with round robin, we also attempt to solve the unfairness problem in a very smart way. That is, if we look at the scenario that there is an intermediate device such as a switch or a router which has incoming packets both from a terrestrial wired link and a satellite wireless link. The obvious difference between a terrestrial link and a satellite link is that the acknowledgements that this intermediate device would be generating would be readily delivered to the terrestrial node. But for a satellite node, it is going to take a considerably long time. Consequently, what would start to happen? The packets coming from terrestrial link would be readily served on this intermediate device, and it would become unfair. Now, if we use node by node virtual circuit based windowing along with round robin algorithm such that this intermediate device takes a packet from the terrestrial link, then does not take any further packets till it processes a packet from the satellite link, and it reverts to terrestrial link and then to satellite link. For these two links, if it toggles between the two, it would make the system fair.